time, and energy particle makes itself at the same time, and it seems to us as if these three entities only make one. Substratum thusna. The functioning of the substratum needs the existence of thusna, and the functioning of thusna needs the existence of the substratum. So, a new fundamental notion, the relativity substratum thusna, is born. The fundamental notions of each one will brighten in the following chapter while studying physical phenomena explained or not by physicists. How can an energy particle move in the substratum thusna without losing its properties? Let's notice that we can deposit the same entity anywhere, anyhow, and we can make it turn, rise it, take it down, and that it remains always the same without losing its properties. This entity is matter, therefore composed of energy particles. We are going to study one of the energy particles that compose this object. Therefore, this energy particle keeps its properties while putting it in different positions in the substratum. It implies that the substratum is composed of groups of cubes which repeat themselves periodically. A group because every cube supports only one energy potential, for example the quarks, etc., which repeat themselves periodically because the same energy particle can take several positions in the substratum. We know that every cube of the substratum is a site for a precise energy potential. We also noticed that periodically repeated group exists because of the displacing of the energy particle while keeping its properties. The problem that arises is that, in order to make displacement, an energy potential change would be necessary, so that the energy particle appears in another point of the substratum that supports its new energy potential. And to the fact, every energy potential represents a certain quantity and shape of energy. For example, energy potential number 1 equals electron, energy potential number 2 equals quark, etc. Then, how does the electron move while staying? The electron itself, although it changes its potential number 1. We're going to study it in what follows. In the beginning, we're going to define the repetitive group of which we spoke above in the introduction. The repetitive group is composed of all cubes of different energy potentials that exist in the universe. Every cube of this group has the energy potential of basis level. For example, the number 1 cube is an energy potential, example of green color, of level 0. The cube number 2 is a different energy potential, example of red color, of level 0, and so on, until we arrive to the last number n cube, that is an energy potential different from all others, example of other color, of level 0 also. As level 0 is the basis energy potential level of every energy cube. We're going to name this group G0, group where the level of the energy potentials of its cubes is the basis level, 0. Successive increase of the level of energy potential of the G0 group. Now, this G0 group repeats itself periodically in the universe while increasing the energy level of its cubes successively as is represented below. This increase makes itself until the maximum energy potential level, n. So, we will have at the end a set of groups of different energy potential. We're going to include all these groups in a bigger one that we will name GF, final group. This final group is composed of all cubes of all energy potentials of all levels that exist in the universe, as is represented below. Recreation of GF. When the successive increase of the level of the GF energy potential arrives to the maximum level n, another GF group appears as continuation of the first. GF redoes the successive increase until the maximum level n, and another appears as continuation of the second and redoes the successive increase until the maximum level n, and so on until the substratum takes its shape in the universe. Finally, Substratum is a group of GF that repeated itself periodically, and this periodic repetition is currently continuous. It's the universe expansion. After having an idea on the constitution of the substratum, we're going to explain how does the displacement of the energy particle in the substratum made. Displacement of the energy particle in GF. Displacement of the energy particle in a subgroup of GF. For displacement of the energy particle inside a subgroup of GF, let's take as example the subgroup G0 and the displacement of the energy particle from P10 to P20 returns back to P20. For that, it's necessary that P10 receives plus delta P21 to have P20. But to the fact that means change of the properties of the energy particle. What means, for example, change of matter at a big scale. It tells transformation energy particles composing wood to the energy particles composing iron, for example. And of course, it generates a displacement, but for the meantime only in the G0 group. Displacement of the energy particle from one subgroup to another in the same GF. For displacement of the energy particle from one subgroup to another, let's take, for example, from the G0 subgroup to the G1 subgroup. And displacement of the energy particle from P30 to P31. It's necessary that P30 receives plus delta sigma 10 to have P31, since the sum of the delta sigma from delta sigma 1 to delta sigma n is equal to delta P. Displacement of the energy particle from P01 into P13. For that, it's necessary that P01 receives plus delta P10 in order to have P11, then that P11 receives plus delta sigma 31 to have P13. Therefore, the energy particle would have made displacement from a position to another in the substratum Thusna, but while changing its properties. What means at a big scale, the energy particles constituting the olive move while turning into energy particles constituting the apple. In other words, also, the olive moves in the substratum Thusna while turning into apple. So, in order that the energy particle can move, it must make a transformation. Either it receives energy or it clears energy, so that it can appear in another side of the substratum Thusna, and so to move. But the problem is that in order to move, the olive must turn into apple. How does it make then that the olive can move while remaining the olive itself? Displacement of the energy particle while keeping its properties. TS secondary time equals 0 implies the energy particle doesn't exist yet. Delta sigma equals 0, there is no change in the energy potential. This graphical representation is the one that I aim correspondent to the one used by the energy particle in order to move from a cube to another in the substratum Thusna while keeping the same interval of properties. In order to come closer from the notion, we're going to take an example. Let's take as example the energy particle P01, and let's put energy particle P01 equals value 1. By the way, in the substratum Thusna, the value 1 represents an interval as is represented below. From 0 to delta sigma 1 is the value 1. From 0 to delta sigma 2 is the value 2. Thus, the energy particle P01 of value 1 belongs to the interval 0 delta sigma 1. We have P1 delta sigma 1 equals to P1 0, and P1 delta sigma 2 equals to P1 1, etc. Where Pxn as n is the energy level of the same energy particle of the same energy potential, and that x is the number of the energy potential, where each number represents an energy particle different from the other, energy potential of level 1, level 2, etc. In the graph, we see an increase of sigma from 0 to delta sigma 1, then a reduction from delta sigma 1 to 0. I would like to remark to you that the progression from P10 to P11 is done of a manner to what the energy potential is superior or equal to P10 and lower or equal to P11. It's what imposes the non-displacement to an energy potential superior to P11. And therefore, the energy particle appears in the cube supporting P11 and remains there. Now, this total energy potential decrease, then it appears inevitably in the cube supporting P10. Therefore, the energy potential of the energy particle decreases from P11 to P10 and appears in a cube P10. And that means another small displacement. But that doesn't stop there, because the energy particle has just made only two infinitely small displacements in the substratum thusnelh. Then, how does the energy particle make a displacement from a cube to a distant other one in the substratum thusnelh? How does the continuity of the movement done? The reception of delta sigma 1 by P10 is not done in a steady and continuous manner, but in unsteady continuous manner. Like continuous fluctuations, what can generate the movement of the energy particle in a continuous way while remaining in the same interval 0 to delta sigma 1. The following graph schematizes it. The fluctuation is divided to F1 and F2, where F1 equals to fluctuation 1. It represents the growth of sigma from 0 to delta sigma 1. F2 equals to fluctuation 2. It represents the shortening of sigma from delta sigma 1 to 0, sense of this displacement of the energy particle. Now the problem is, since there are several GF, there are several G1 and several G0, then in what cube does the energy particle appear while changing its property, its energy potential? What means, in what sense does it move in the substratum thusnelh? It's not only related to the sense of the movement of the energy particle, but to the forces fields of the cubes that surround the energy particle too. For example,